So let's look at two different multi-scale data sources and see how they think about organizing their data and that sort of thing. The United States Geological Survey organizes their data by quadrangles. So when we're talking about quadrangles, this shows the entire globe here. And as we can see, of course, the latitude and longitude are changing by degrees. So each time we move from 0 to 20 degrees here, we're going through 20 degrees of longitude as we move across here, and moving from here to here, we're moving through 20 degrees of latitude. The reason they call these quadrangles is because they measure by either degrees or they're dividing those further down into minutes. So each degree would be comprised of 60 minutes. So this would be 1/4 of 1 degree of longitude change here. And this would be 1/4 of 1 degree of latitude change here. And so this would be called a 15-minute quadrangle. The reason it's called a quadrangle is it's not quite a rectangle because it's coming right off the globe, so that the distance of this latitude line here further to the north will be a little bit longer than this distance of latitude line here, which is a little closer to the South Pole in this case. So this 15 by 15 minute quadrangle could then be divided into 4 7.5 minute by 7.5 minute quadrangles if we wanted to do that. And that's the way that the USGS set up their grid in order to map the United States. So we have these different quadrangles here. Once again, here we're going from 41 degrees north to 42 degrees north, from 100 degrees west to 101 degrees west, and we can divide it into all of these different sizes. So this would be, this block here would be a 1 degree by 1 degree quadrangle. This entire thing here, 1 degrees by 2 degrees. And some more common ones, we have the 15-minute quadrangles, which would be 1/4 of the way across one of these degrees and 1/4 of the way down one of these degrees, and the 7.5 minute, which would be 1/8 and 1/8. So we can kind of think of all of these different scales of mapping, potential scales of mapping that we have here for USGS data. And of course, the reason we want to have that is to make more or less detailed maps for multi-scale mapping. We can see here, if we're at our most detailed map scale here, such as 1 to 24,000, we can see a lot of details, including all of the individual buildings in Gorham here, all of the individual roads, and it's very detailed. But as we zoom out, and now we're not able to see all that detail anymore. We no longer see the houses. We don't see all of the roads going through there, but we still see some of the main roads, and we see the outline of Gorham here. But by the time we're zoomed out once again at a different scale of mapping, now we're just seeing the major roads going through Gorham. We still get a little bit of an idea of the outline here, but not nearly as much detail. So for detailed mapping, it just depends on how much detail you want to show, what data set you would choose in this case, and or what maps you would use in order to do that sort of mapping. And of course, people that go hiking might want to have the most detailed mapping. Other people looking at a broader area might just want to know where the location is. Another example of a good multi-scale data source is natural earth data. This was put together by cartographers so that the GIS data that you download here is appropriate for mapping at these scales. And you can see they organize it from what they call large scale, right, but is not nearly as zoomed in as the USGS stuff, starting at 1 to 10 million, and then going to 1 to 50 million and 1 to 100 million. And they kind of show these just screenshots to show what your map might look appropriate as if you were using this sort of data. And then they organize the data into cultural, physical, and raster data sets. But this is something that people have put thought into as far as what looks good at these scales. And they've already taken into account all of those things, such as how simplified or how smooth the lines have to be in order to look appropriate for mapping at those scales. So it's just a scale consideration that's been put in here, and then multiple data sources that are available for mapping at those scales.